Good evening, friend. Today I will discuss about on the topic of nuclear and particle physics. The topic is the basic nuclear properties. On this chapter, we will discuss about the nuclear size and shape. As we had seen in previous episode, every atom have a nucleus. So, what is the nucleus size and their shape? I will come on the fact on the derivation basis. The unit of a nuclear length is called as a Fermi. We represent this small fm. 1 fm is equal to 10 to the power minus 15 m. On the base of Rutherford scattering formula, energy of alpha particles when incidents if too high, then the alpha particles are very close to each other. The distance between these particles are in few Fermi. Then the Rutherford's a scientist was derived a formula on the assumption that is the nucleus was a point particle. Suppose the radius is r, then rho r is equal to Z e psi r square, where rho r is the nucleus charge distribution as per quantum mechanics. This formula derived by Rutherford by making assumption as a nucleus is a point particles. This formula is very useful in the nuclear physics. That is the nucleus charge distribution according to quantum mechanics. Rho r is equal to Z e psi r square, psi r whole square, where Z is the atomic number, that is the number of proton in the nucleus, psi is the wave functions for one these protons, and psi r square, psi r whole square is the probability density of one proton. The physics is very interesting subject. Now for electron, the case is like this. The projectile charge Z is replaced by 1. In Rutherford scattering formula, the correction was made by the scientist Mott. Mott derived, Mott corrected the formula of Rutherford of the charge distribution. We tell that d rho upon d epsilon mod is equal to d rho upon d epsilon Rutherford, that is d rho upon d epsilon Rutherford 1 minus v square c square sin square theta by 2. This is the formula, you can see. So d rho upon d epsilon is equal to d rho upon d epsilon mod. This is in the bracket f q square a whole square. Velocity is the velocity r is where v is the velocity and fq square is called the electric form factor. Q is the momentum transferred by the electron and q equal to 2p sin theta by 2. P is the momentum of an incident electrons. If you see the figure, this is the figure that is not coming from this. Not coming. So suppose the nucleus is like a spherical and one wavelength is spherical and one wavelength is coming from this sphere and other wavelength in downside the sphere. The wave reflected diverted from the nucleus, downside the wave also reflected downside of the nucleus through the angle theta. For a spherical symmetric charge distribution, now the derived the formula fq square is equal to 4 pi h zeq, that is the integration of rpr r rho r sin q square upon h dr. Then rho r is equal to 3ze 4 pi r square, r is smaller than small capital R. This is equal to 0, r is greater than r. So the integral in the Fourier transform fq square is equal to 3h upon qr the whole cube and sin qr upon h minus qr upon h cos qr upon h. So many models are given by the Saxon-Wood model and a lot of graph are plotting and different experiment by done. So these are the some you see. This is the some fact, some graphs. These are the graph. This is also graph. This is also graph. This is also graph. This is the graph.